Hey everybody, it is still snowing outside, and it is still Saturday, but you're not getting this video today. I'm going to give you this video tomorrow night probably, because I've already given you 2 videos in one day, and like I said in that announcement, I don't want to overload, and I don't want you to, I want to get you all your resources early, so you have a lot of time to work on the assignments and let things steep, but I don't want to overload you. I'm not interested in that. Hold on a minute, let me mute the hockey game. Oh, Toronto and Pittsburgh are playing. They're tied at 3 in the third. Islanders don't play again until Monday afternoon. Special President's Day game. They play the Wild at like 1 o'clock. But I digress. All right. We are going to do a homework assignment. And we are going to use all of the different skills we've learned in Unit 3. We're going to use functions. We're going to use file I/O. And we're going to do things in a modular fashion and create a library. Okay? So, for my homework assignment, what I usually do in this case when we get to this point in the course is I will go grab, let's say, 3,000 random numbers. And my homework assignment is going to be harder than yours because I'm actually going to be rustling up my own data. When you get yours, I'm going to give you the data. I'm going to examine those random numbers that I generate to see which ones are palindromes. And if you're not familiar, a palindrome is something that reads the same way forwards as it does backwards. And we're going to get numbers. So if I have like 1, 1, 2, 1, 1, well, that's palindrome because it's the same forwards as backwards. Single digits, palindromes. Okay? You'll get the gist of it when we look at it. So basically, I'm going to have 3,000 random numbers. And what I have to do is I have to count how many palindromes are in that list. All right? So we're going to write a program that does that, but we're going to use all of the things that Unit 3 has taught us. Plus, we're using all the things we've done all along, because we're going to use, obviously, we're going to use loops. Obviously, we're going to use lists. Obviously, we're going to use everything. Computer programming is like mathematics in that it's a pyramid. It always builds on top of what you've learned in the past. All right? All right, so let's get started. The first thing I'm going to do is I'm going to go rustle up some data. Let me get a time check. 9:20 p.m. Because I'm going to show you this is not a difficult process. When you get your homework, you're going to, new Steven Pinker book is out. You might want to go check that out. I think mine's already on the way. I am going to go to a very special place in the hearts of all computer science professors, random.org. And you're going to see this is where we come to get the random numbers. If you're ever given random numbers, this is where they went and got it. Because it makes your life very simple. What I'm going to do in this case is I'm going to go to numbers and I'm going to go to integers. And I'm going to generate 3,000 random integers between 1 and 10,000. So I can get 4-digit ones. And I'm going to format them in, let's say, 10 columns. And then all I have to do is say, I get the numbers. And look at that. Random numbers. There's a lot. Do I see any palindromes? I don't know. You think at 3,000 numbers, you're going to have a couple, right? Nothing jumping out at me. All right, so what I'm going to do is I'm going to highlight that top one. And then I'm going to go down, 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 down. And get right at the bottom of that 9. And then I'm going to copy. Then I'm going to open up Notepad. And I'm going to paste. Look at that. And all of a sudden, I have them in a format that I need. I'm going to save as... And I have already, because I am a good doobie, set up a directory for us. Python Data Science, Spring 2018, Unit 3, Palindromes. And I'm going to call this rnums because they're random numbers, .text. Boom. So now we have our data. Okay? Put that down there. Hey, word to the wise. Randomnumbers.org. Random.org, go check it out. Because you can see, you learn a whole bunch of things about random numbers, when they're used, how they're used. Very cool, little nerdy, mathy thing, but it's cool. It's puzzle solving and it's neat. Fits in with Project Euler. Go check things out at random.org, okay? Okay? Okay. Now, what do I want to do now? I have my data. Got me some data. Right? I want to examine this data and see what is a palindrome. But I'm going to do things a little different way. First, I'm going to go grab me my Python active window, and then I'm going to grab a new file. And I am going to call this file first I'm going to say palindrome library, because eventually it's going to be a library. And I'm going to just do that. And then I'm going to name it. What am I going to name it? I'm going to put it in Python Data Science, Spring 2018, Unit 3, Palindromes, and I'm going to call it tools.py. Okay? And what I'm going to do with tools.py is I'm going to write a function that determines if a string is a palindrome or not. And you're going to see that the reason I do this is that because in Python it's incredibly easy. Okay? Because there's a little trick. All right? Once I write that function, then we're going to save this and have our own custom library. Then we're going to write a main program and use the library there. So what am I going to do? I'm going to say def because I'm defining a function. I'm going to call the function isPal because it's going to return booleans, either true or false. So it's almost like asking a question. Is this a palindrome? And then it'll say true or false. So I will call the thing that it looks like is ppal for potential palindrome. And then I'm going to see if ppal is the same forwards as it is backwards. So I'm going to say if ppal equivalency is equal to ppal, but watch what I do with the slicing. Can you see what I did there? I'm saying is the string ppal equivalent to the string ppal, but look what I did. Beginning is a default, end is a default, go backwards. That's the string backwards. So basically what I'm telling Python is, hey, is the string forwards the same as the string backwards? And if that's true, then I have a palindrome. So I'm going to return true. Now, you're either palindrome or you're not, right? So, So if it's not, I'm going to return false. You know what? We're done. We are done. But I'm going to do a thing called test it. And then what I'm going to do is I'm going to print isPal, and then we're going to test 1 1 2 2 1 1. That, my friends, is a palindrome, so it should say true, and it does. Good, good, good. Now, if I just put a 3 in the middle of it, boop, still true. I like it. Uh-oh, that is not the same backwards as it is forwards. We got trouble, and the river said, look at that. It picked it up, though. All right. Now, we got strings here, so we don't have to just do numbers. We can do race car. That's a popular palindrome. True. The one everybody learns when they're a kid is radar. We'll try radar. True. Okay, we're in now. I'm just going to put some random nonsense in the middle of it. Comes in false. I think we're in pretty good shape here. Okay. So we have a function that tells us if something is a palindrome or not, which is pretty cool. Now, just because we're going to get back to it later, I'm going to do one more thing. I'm going to create a variable called Hernandez, and I'm going to set it equal to 17. Okay? We're going to get back to that in a second. If you're a Met fan, you know what I'm talking about with that particular variable. All right? He wanted 37, but he couldn't have it because it was Casey Stengels and it was retired. I digress. So now I save tools.py and I get rid of it. All right? Because we're not going to use it for a while. So what do I have right now? I'm starting to build up some stuff here. I have my data. There's 3,000 random numbers in here. And I now have a little library off to the side that has a function that tells me true or false. If I give it a string that's a palindrome, it returns true. If I give it a string that's not a palindrome, it returns false. Okay? So we're starting to build some stuff up here. I'm going to grab one more new file. All right? Because remember, this is the part of the show where we talk about modularity. Main program for finding palindromes. Okay? We're being modular here. We're taking our different logic and we're separating it out and we're compartmentalizing. Okay? So, what am I going to call this? Good question. Very good question. I will go to the proper directory first. Unit 3, palindromes. And I will call this mainpal.py. I don't need that there. And we'll just call this mainpal. Okay? So, what's the first thing I want to do? First thing I want to do is read in my data. So, what am I going to do? I am going to open this file and give it a file handle. I'll just say F and I'll assign it open. I'll just type it in. rnums.text, comma, R. I wonder if I can mix and match within the statement like that. So now that I have F, I'm going to say data assigned F dot read. All right, and that should read in all my data. And then I am a good file citizen, so I'm going to close. Okay? And just to test things, let's print data. All right, are the programming gods with me? They are. Look at that. There's my data, and there's my numbers, all read in for me. Now, what's interesting, look, that is a lot. Okay? So I've read everything into a string called data. But you've got to realize something here. We are not your average Joes on the street. We're programmers, okay? So when we look at this screen right here, most people see 10 columns of numbers. We don't see 10 columns of numbers. Think like the Matrix. We don't see what everybody else sees. We see number, tab, number, tab, number, tab, all the way down until we get to here. We see a new line, okay? We see \n. Backslash T, backslash T, backslash T, backslash T, backslash N goes to the next line, okay? Because that's the way it was formatted when we got it from random.org. We're going to use that fact because now it's time for us to clean our data and get it in a usable form. In our case, a usable form is going to be a list because then we can iterate over that list and use the function we made to check if we've got palindromes. All right, I'm not going to do that right now. What I'm going to do is I'm going to clean my data. That's exactly what I'm going to type. Clean my data. I'm going to say data equals data dot replace. Now, here's the trick. What do I want to replace? Remember when we did it in the second review video, we replaced the quote, double quotes with nothing because we wanted to get rid of them. This is a different situation. At the end of the day, what do I want? What's the condition I need? I need all of my numbers to be separated by the same thing because that's what I'm going to use as a delimiter in my split. Right now, I have my numbers separated by two different things, tabs and new lines, okay? So I don't want that situation. So what I'm going to do is I'm going to take my new lines and I'm going to turn them into tabs. All right, so then it'll only be tabs separating the numbers. Then I can use a split like we did with the comma separated value in video 2. Instead of splitting with the comma as the delimiter, I'm going to split with the tab as the delimiter. And that's how we're going to pull this off. So watch me work. I'm going to replace the \n's in this particular data set, and I'm going to replace them with \t. Okay, so now when I print data, watch what happens. Okay, look at this. It'll go all the way across the screen because there's no more new lines. All right, the only thing wrangling that data in there is the way that idle prints it, the way that idle keeps it in the same window. If we could go all the way across the screen, it would go all the way across the screen because there's no new lines, there's just tabs. All right, and there's your 3,000 numbers all separated out there. It's a lot of data. Well, it seems like a lot of data because we're wrangling it here in these little programs, but compared to other things, it's not a lot of data at all. It's nothing. It's a speck. All right, so I'm going to get this back into a reasonable state. You can see it's slow because it has to redo everything. So now what do I do? Well, now I'm in Fat City because now all I have to do is say data is data dot split. And what am I going to split by? \tab. Okay. Now remember, split, the return of a split is a list. So data is now going to be a list. And all of those numbers represented as strings, but all of those numbers are going to be in my list. All right. So now when I print data, takes a while, but look, it's a list. See the ending bracket? See everything is in single quotes? So now I have a list. So now that I have a list, I'm in Fat City, right? Iterate over the list to find palindromes. Okay? So, I'm going to iterate over the list to find the palindromes. What am I going to do for I in data? I don't need range. I have a list. I'm going to iterate over the list, right? What do I want to do? I want to use my code that I wrote before. Okay? Let me skinny this up. I want to use my code that I wrote before here, but I have to do something first. What's that? First thing I have to do is import it, like we did in the last video. So I'm going to import tools. Remember, tools is in the same directory as this code, so it's going to find tools.py, and it's going to import it. So for I in data, what am I going to do? I'm going to say if tools.isPal of I, if that is equivalent to true, what do I want to do? And right now I'm just going to print it. Okay? So we're going to go through that whole list, and if isPal I is true, which means it's a palindrome, it's going to print it. Let's see what happens. Taking a while. And there's 3,000, so there might be a lot. All right, let's look at some of these numbers. 8998, yes. 2, by definition, a single digit is the same backwards forward, so single digits are palindromes. 242, 3663, I love it. 1441, these are all palindromes. So it leads me to believe that we're in pretty good shape. Again, we haven't done the assignment, though, because we need to count how many of them there are. Okay? So what are we going to do? We know how to do this. Actually, we know how to do this twice over now. I'm going to set up a counter. So if that's true, I'm going to say C plus equals 1. And then when I jump out, I'm going to say print there were C, comma, palindromes in the list. And then when I run, I'm going to print them all out, and there were 48 palindromes in the list. How about spelling palindromes correctly? Would that help you out? Would that pep you up some? There were 48 palindromes on the list, okay? Now, once we do that, we don't really need to print anymore. So we can just rerun it and say there were 48 in the list. All right, how can we do that in a more Pythonic way? Well, it's easy. We can say my pals is an empty list, and then instead of a counter, we can say my pals.append I. So we will put it in a list instead of doing a counter every time we find it. And then what are we going to do when we want to know how many there are? We're just going to do a len on the list. So if we do this, we get 48 again. Same thing. Because this time we've put them all in a list and printed out the length of the list, which is the number of items in the list. But again, I like to do things like this because now if I want to print out my pals, I have it. Okay, so now we have all the palindromes in a list that we can play with and print and do all of that. All right? All right. Done. Now, what was the time when I grabbed it? 9:20, right? 17 minutes. It took us 17 minutes to do this. All right? We have data right here that we wrangled. We created a library with palindrome, and we will get to Hernandez in a second. But I just wanted to stop because we've completed our assignment. And then we wrote main code where what did we do? We read in our data, we cleaned up our data, and got it in a list so we could use it. And then we iterated over that data using our palindrome function and saved in a list all of the palindromes. Then we counted them. That was what we wanted to do. And we found out that there were 48 of them. I like it so much I'm going to run it again. Look at that. There are 48 palindromes in the list, okay? And there you have it. All right? I'll talk about the constant first. One last thing I'm going to do at the bottom here is I'm going to print tools.hernandez. Did I spell it that way or with a capital? I spelled it with a capital. Good, I should. All right. Rerun my code. You can see right there at the bottom it says 17. Look in this code. You see a 17 anywhere? No, because it was read from the library. A lot of times in libraries we define constants. The math library has pi, has e, has a bunch of different things. We'll call them constants because if I'm accessing it from here, I can't really change I can't change it. I can just read it in. So if I say to you in an assignment that I want you to define a constant, that's what I'm talking about. Just create a variable that's kept in the library, and then you can access that variable by putting the library name in front of it, .Hernandez, and then you can print it out just like we did there. That's all a constant variable is. When I say constant variable, that's what I'm talking about. Something you define in a library for use in a regular program if you bring it in. Okay? And because we've imported tools, we tell it tools Hernandez, and it prints 17 because it was defined here in the library. All I'm talking about. All right? Because in the past, I do. When you get your homework assignment, you're going to see I'm going to make you define a variable. And you're going to use that variable in a couple calculations in your main program. And I want you to know what I'm talking about. Well, constant variable, there's no secret. There's no shock. It's not crazy. Just define a variable in the library and then use it inside of the code. That's all. That's it. Okay? So we're done. All right? But think about it. Think about what you did in the first part of the slides. Functions. Okay? We defined our own little function here, isPal, and it returns true if something's a palindrome and false if it isn't. Think about file I/O. We got 3,000 random numbers here with funky tabs and new lines and all of that in between. What did we do? We read it in. Open, read, close. All right? We got it all in one big string, and then we took that string and we manipulated it and turned it into a list that we can use. We use the replace. So there's only one delimiter that I can use in a split, which turns my huge string into a list. Then we iterated over that list, and as we did, we used our function over here, because when we imported our library, we then used our custom-made library in our code. That's the third part of the unit, modularity. Okay, we created our own little library off to the side that we can use. Okay, and then we use some of the old things we know about lists to populate a new list, and then we just use len to print out how many there were. Okay, I like to do things this way because then you have this, my pals, at the end of the day to do what you want with it. When you do your homework, you might want to take the results of one thing and then use it as the input for the next thing. Hint, hint, wink, wink. Okay? So that's why we do things that way. It's more Pythonic just to use lists. Remember, they're just empty bookshelves. It'd be great if you had empty bookshelves laying around, right? And that's all it is, all right? I am not going to put this code up on the web, but it's right here. I mean, this is the entirety of the code right here. Okay? So if you want, freeze this screen, look at it, play around with it, and you know, this is very similar to what you're going to be doing for your homework. So this is an important video to have and to look at. Okay? All right. Announcements. I am going to wait. Am I going to wait? Because I don't know when I'm going to do the Euler video. I may do the Euler video tomorrow now that I've done this tonight. Because I'm going to be in the cave tomorrow, snow or no snow. The snow's still coming down. I'll wait to do the announcements. Because I know I'm going to be in touch over the next couple of days. And I know I'll be in touch. I'm going to give you the assignments probably Tuesday. And by then I want you to have all the resources. But I'm going to tell you that it's already the 17th of February. And the midterm is going to be due on the 11th. So if you haven't gotten chugging on that, start chugging. And because on the 11th, or very shortly right after, I'm going to give you the information you're going to need for your final project, which is odd. We're already talking final project. It feels like we just started. I want you to start thinking about groups. This will be better defined when we meet in class in a couple weeks. Or maybe I'll do an announcement next week. But start thinking about groups. Our final project is a group project. And you're going to join up in groups of 4 and or 5. It's up to you. If you want to do 5, you can. And there, usually you'll see when I put out the call, there's different roles that people can have and different things that people can do. And the final project is broken out into a couple different parts: a proposal, a design document, the actual code, a demonstration, not in person, but with, slides or YouTube video or a Prezi. And I'll show you some examples, so you'll be okay on that. But it's about time in the semester where we're going to have to start thinking about forming groups. Okay? So just keep that in mind in the background. Right now, you have your resources for Unit 3. You have your slides. You have your Zell. You have 4 now review videos, okay? And very soon, in a couple days, I'm going to give you the assignments, okay? This is where you're the learner. You're absorbing all of these resources. You're engaging with them. And then come Tuesday, you're going to get the assignments. Then you're the practitioner. That's when you take what you use, and you take the hammers and the nails and the wood, and you build that house when you do your assignments, okay? And then, it's still a lot of time. Remember, February's short. So it's the 17th, and usually you're feeling good, like that's halfway through the month. But you know what? February's only got 11 days left in it. And then this unit ends on the 6th. So we've only got about 18 days left, okay? So Unit 3 is going to go quicker than you think. So make sure you get all this stuff squared away, all right? All right, then I'm going to get out of here. You must be sick of these videos by now. I've shot like 3 of them in the last 24 hours. You must be sick of this. And I don't blame you. All right, I'm going to go shovel snow. I'm going to go shovel my walk for the first iteration. And then you can get all the crud off my Jeep, maybe run it for a while, see what's going on. All right? All right, then I'm going to get out of here. You be good, and I will talk to you later. Bye.